Hello everyone, I hope you all are doing well. So today we will be starting with the chapter Permutation and Combinations. So if before you haven't done binomial theorem, it is recommended that you first study that chapter because more or less the concepts of combinations are going to come from that chapter only. Now talking about this chapter, this is not a very difficult chapter. There are not too many formulas in this chapter. There are, but only a few. Mostly the questions of this chapter are solved using your common sense. So definitely a chapter which you should practice a lot, because without practice you wouldn't be able to solve questions of this chapter. And again, the concepts of this chapter would be used in probability as well when we study that. So keep in mind these things and let's start. So talking about the subtopics in this chapter, first we'll look at a brief introduction as to how combinations and permutations are and what are we talking about. Then we'll look at factorial. Again, factorial is something you have already studied. We've seen this in binomial theorem as well. Then we'll look at a few PNC, their methods of solving PNC. These are again different methods of solving PNC: formation of groups, Beggar's method, derangement formula, and there are a few more. And so we'll look into those and we'll solve our questions. So without further ado, let's start. So firstly, the fundamental principle of counting. What are we counting here? We are counting the number of ways or number of possibilities anything can happen. So for example, if I'm saying, let's say there are 4 people and I want to arrange them in 4 chairs. So what are the ways in which I can arrange them? It can be a lot of ways, right? The first person can sit in the first chair, or the first person can sit in the third chair, or the second person can sit in the second chair or the fourth chair. So there can be a lot of ways. So that is what we are going to count in this chapter. So firstly, the fundamental principle of counting. I hope you all remember we had studied in sets as well. Whenever you see a union or you see an OR, that time what do? We add our possibilities. And whenever we see an intersection, that means we will be seeing an AND. That time what do? We multiply our combinations. So exactly that is what is being told here. If an event can occur in m different ways or n different ways, that means it can either happen in m different ways or n different ways. So here you can see that the word or is being used. That means the total number of ways in which you can choose this event to be occurring, that would become m plus n. So that is what has been written here. Now similarly for multiplication as well. Now let's say if an event is occurring for m number of times, an event can occur in m different ways, and then it has to be followed by, let's say, different n ways. That time what do we say? There would be m into n chances. So let me show you an example. This would make your doubts clear. So for example, a student can choose one elective course from either category A or category B. So let us write it down. Here we have category A, here we have category B. Here I have let's say courses. So I have C1, C2, C3, C4 and C5. And in B category I have 3 courses. That means let me write it down by D. D1, D2 and D3. How many total choices does the student have? So first of all, he has to choose only one elective course. It can be either from category A or it can be from category B. That means in total he has, of course, 8 choices. So that would become my answer, right? So addition principle would be used here, right? Because I can choose either from category A or is being used, or category B. Now let me twist the question a little bit. Now what if I say the student has to choose 2 elective courses. 2 elective courses. One from A and other from B. So other from B. Now what are the total number of combinations or choices that the student has? Now I'm saying that he has to choose one from A and one from B. So from A he had 5 choices. Now since I'm using AND, that means I would multiply this, because from B I have 3 choices, so this would become 15 combinations. Now you must be thinking how there are 15 combinations. So from A, let's say if I choose C1, and from B I have 3 choices. Now I can choose either D1, my other combination could be C1 D2, my other combination could be C2 D3. I have to choose 2 courses, right, from A and B. So it can be C1 D1, C1 D2, C1 D3. The other could be, if I choose let's say C2 from my A, then I could again choose D1. The combination is different, right? I'm choosing C2 and D1. Earlier I was choosing C1 and D1. So the combination becomes different. So similarly, I can choose C2 D2, C2 D3. So this is how my 15 combinations would become. Similarly, I would carry on for C3, C4 and C5 as well. So that is how my combinations are generally calculated. Now this is a question of multiplication principle, of course. A cafeteria offers the following options for lunch: 3 types of main courses, 2 types of drinks. How many total combinations can a person choose? That means first of all, I have to choose one from the main course and I have to choose one from the drinks as well. That means either I can choose pasta and coke, or I can choose pasta and lemonade, or I can choose pizza and coke, or I can choose pizza and lemonade. So similarly, this would carry on for burger as well. So if I have 3 choices here and I have to choose one from this one as well, so my total combinations would become 3 into 2, that is my 6. For each main course, there would be 2 drink options, of course. So that is how your logic basically justifies this multiplication principle. Now talking about the factorial, this is something you already know. You have studied this in your class 10th as well, and in binomial theorem also we used this term a lot. Any number represented by an exclamation mark next to it becomes a factorial notation, and it is written as n factorial would be written as n into n minus 1 into n minus 2, and this goes up till we reach 1. So if I have 4 factorial, it would become 4 into 3 into 2 into 1. Now a question. Now the same example that I had taken earlier, in how many ways can 4 people sit in 4 chairs? Now the total number of arrangements here would become 4 factorial. Now why is the reason? Now let's say I have 4 chairs and I have 4 people. Let's say 1, 2, 3, 4. These are my 4 people and these are my chairs. Now let me do it one by one. If I choose only the first person, let's say I've chosen the first person. Now what are the ways in which I can make him sit in these 4 chairs? Either he can sit in this chair, either he can sit in this chair, either he can sit in this chair, either he can sit in this chair. So there are 4 ways in which he can sit in this chair. So 4 becomes 1 here. Now once he has been seated, now how many chairs have I been left with? It doesn't matter which chair he has been seated on. The only thing matters here is that he has been seated now. Now how many chairs are left? Now I have only 3 chairs left. Now I will choose the second person. Now how many ways can the second person be seated? He can either be seated here, here or here. So it would become 3. Now once 2 has also been seated, now I would be left with only 2 chairs. And if I was to find out the ways in which 3 can be seated, it can be 2. And if I check for 4, it can be just 1. Now, since all these ways that we were discussing, one can sit either here or here or here or here. So this was that was going on was OR. That is why we added each and every possibility. So this possibility we considered as 1. This one was 1, 1, 1. So added all of those, we got 4. Similarly for 3 as well. For 4, there wasn't any choice. It was just 1 chair left. So he sat there. Now, once this thing has been done, once the first step has been taken down, 1 has been seated. Now we have to seat 2 as well. So this would be AND here. Now after 1 is seated and 2 is seated and 3 is seated, then we can make 4 set, right? So this would be AND here, and this would be an AND here. So that means my answer, or total number of ways in which I can seat these 4 people in 4 chairs, would become 4 into 3 into 2 into 1, which is nothing but my 4 factorial. So this is generally how, if you have to arrange people in, let's say, a few number of things, that time you arrange it using the factorial notation. So this was a proof of how we got the 4 factorial. You must remember that not every time you are going to go solving the question using this method, right? So you must remember, when there are n number of let's say arrangements getting done in n number of arrangements, that time we say our answer would become n factorial.